The next gentleman coming to the stage is an astrophysicist, a rocket scientist, a hazelnut farmer. Also, when you open your app and you type in that destination, you get directions and they send you to the other side of the world, you can also blame this gentleman here partly for that. He's a VP of Impact at Satellogic. It's my pleasure to introduce Dr. Sanchez-Andrade Nuno, or thankfully, as he prefers to go by, Bruno.
Well, thank you very much. I want to start making a reflection which is absolutely fascinating and inspiring to be the minority between these two amazing women talking about the future of everything, space and ocean. So I just feel part of that. I'm hopeful when I see you speaking, when you transpire all this passion. So I want to share with you in these minutes a reflection. This is a reflection of a path that has been not easy, and hopefully is something that I can also get your help to move forward. And this is in the context of the title of the event that brings us here, FutureTalks, and the future of everything. What are the biggest questions that we face today, right? That's why you're all here. And if I start to think about what those questions are, I mean, you think what those questions are, probably one of them is climate change, or maybe is polarization of politics, or maybe is feeling connected, or there are artificial intelligence. There are so many questions out there. And then we need to make them a reality. So I have this thought experiment that I want you to do. Imagine you are with your president, or with your head of state. Imagine it's someone from America, so it would be Trump, or imagine someone from another country, either democratic or not. And you're an expert on that field. Say climate change. Maybe some of you are experts in climate change or the effects of climate change. And then I ask myself, what would I say to this person? And it's a very interesting process because we blame the change into the traditional change makers, which could be, for example, presidents, CEOs, heads of states. But then when we are tasked with the question, okay, I'm here now, I'm with you, what should I do? This is something that has happened to me. I was with the president of the World Bank, and we're talking about climate change and what my role is here. So I'm a scientist. I studied astrophysics, as you were saying, then I work with rockets, but they ended up working for the World Bank. It makes absolutely no sense, right? The bank doesn't have rockets, I can tell you. But the answer to why I did this thing, is because I started to struggle with the idea of what is science. Or when I say science, I include also engineering, mathematics, right? The whole STEM. And I don't know how many of you would consider themselves students or practicing science. Could you raise your hands? Just to get a sense. Okay, there's a fair. So what I'm trying to do is challenge your idea of what science is, or better said, how it could be complemented. I think when we think of science, we probably think of research. We probably think of academia. We probably think of making papers, like journals, peer reviews. But then, I wonder, me as a scientist, is my role when I'm in this table with the head of state to say, read my paper? That's not gonna go anywhere, right? I think there is a role for scientists to, yes, do those papers, that is great, do research, but then engage in the real solutions. So that's the quest I'm trying to go for. How can we think of science outside of academia, outside of research, and engage directly on the issues at hand? I'm gonna try to put some examples of when things doesn't work and when things work. And hopefully through that method, I can steer some light into this path that I put myself into. There is this, I started to tell you this story yesterday that I couldn't finish, so I'm glad to say it now. There is an explorer of the National Geographic called Enrique Sala. He's a good friend of mine, and he was an oceanographer. He was also studying the effects in the corals of climate change. And he was a very respectful and respected scientist making a lot of papers. But he said, I am tired of being described, the witness of the destruction of climate change. I'm tired that my job is to describe how things are getting worse. So he left the research academia, and then he started thinking, what can I do? And then on one side, he said, okay, let's think about the other things I was not taught in school that are also important here. Commercial uses of the ocean, history, culture, economics, diplomacy, and then what could we do with this? And then he developed this idea of fish banks, which basically means, to say it quickly, that when you protect a section of the ocean and you don't fish in them, the overflow of the fisheries and the biodiversity created in this protected zone creates more catch of fish than when you don't have it. So it realized that there is a way to make it compatible to protect areas on the oceans and to create commercial entities or do tourism, so to visit the biodiversity of these places. But then he made this paper with the Minister of Foreign Affairs of the Netherlands. He made these papers with a think tank, with activists. So he tried to integrate things that normally we don't think about science. And then he went even further. And then he convinced donors to start an exposition to a series of expeditions to explore these pristine seas. It's called the pristine seas. To show, like you were saying like we were seeing now, how beautiful there is. And then he said, okay, now I have the scientific backing, I have the connection of the stories, now I'm going to go and work directly with the governments to lobby for the creation of these marine reserves. It is hard to say how many of these are being done because of the work of Enrique Sala, but since his work, he has done 26 expeditions, and 18 more marine reserves have been created to an area bigger than Europe. That what this person has done, leveraging his skills as a scientist, but also other factors. You get the idea that how this is not something we typically study in science. We study that science is about creating knowledge. We study that the value of a scientist is based on the knowledge they had. And I refuse to accept that I am a walking dictionary. I can tell you the speed of light, I can tell you what happens in the sun and all these things, but it's not my role in society. I think my role in society is to use these skills for whatever problem there is. And that is the reason I left the rocket science postdoc I was doing with NASA and I started exploring what could I do, for example, in the World Bank. Or in Bhutan, when I lived in Bhutan for a while and I was working on hazelnuts. That was the comment on planting hazelnuts. And my role was the same. I was an astrophysicist, but it was not the knowledge in my head about astrophysics that drove my value in the company. It was my belt of skills to absorb complexity, to make hypotheses, to figure out how we can understand what is happening. Not only the data, because data doesn't change the world, people change the world. And when we understand the data, we also need to understand other things, like culture, like religion. And if you understand those things, maybe you realize that the solutions you had that makes a lot of perfect sense doesn't work because, for example, religion issues. Imagine that there's a breakthrough and the cancer pill treatment comes from pigs, an enzyme that comes from pigs. That will be a problem for a lot of religious people. We need to integrate those things. It's just an example I made up. But my point is that if we want to have an impact with science, papers is not the way. We need the papers. The IPCC is the International Panel for Climate Change of the UN is an extremely important part of the solution to what we do with climate change, but we need to incorporate other factors. And if any of you is in the position to influence these change makers, president or whoever it is, and you understand climate change, your role is not to read the IPCC report. It's going to say, hey, we need to stop the CO2, but 10% of my people work in the plastic industry. How do I work with that? I came with a plane. How do I work with that? How I make it compatible that I'm consuming a lot of CO2 for making this trip, which, by the way, I have to add a footnote, the whole event and what we're doing is carbon offset. So that's great. It's a possible way we could integrate all these other factors. That's what I'm talking about. I think the climate change paralysis that we have, the witness paralysis of science of climate change in a good respect, is because this segmented mindset of science to say, hey, if we do science, it has to be isolated, it has to be repeatable, so that I can create repeatable knowledge and facts I can falsify. That is all true. But when you want to have impact with that, you need to incorporate other things. There's another example of when it breaks, when it doesn't work, that I wanted to share. And then I'll share examples when it does work, so not to have a only negative side of the equation, right? And that is with the discovery of HIV, or AIDS, when it happened. So HIV is a virus, a retrovirus that creeped into the population, starting with the gay community and drug users. So when it started to appear mostly in the US and in San Francisco, the scientific community didn't want to do anything. The political community didn't want to do anything because it was a big taboo. It was not a career-building path. It was not something that was given money to do research. So because there was no emphasis on this impact, but on the research, on the knowledge creation, people didn't want to study. 1982, we had evidence that there was something on the blood bank supply that was also being shared with people undergoing operations, or there were hemophiliacs getting transfusions. But there was not enough study of the scientific community. When it became a big problem, the incentive swung to the other side because the Nobel Prize was at stake. And the French team and the American team were competing to get the Nobel Prize. The incentives, again, were on knowledge creation, on absorbing the complexity by your own team to get the recognition that you need to get more funding to continue as a scientist. From 1982 to 1985, when it was discovered that there was this virus, what later was called the HIV, more than 7,000 people died because of this lack of incentives of focusing on the impact than on the knowledge creation. That is a lot of people. And that, to me, is a consequence of focusing on science as research. If I ask someone, I've done this for many years, if I ask someone what they think science is, they tell the definition of research: the creation of knowledge, the use of a scientific method, making peer reviews. And what I say is that this is all true. We need to do research. But to me, science is a set of tools by which you not only get to knowledge, but you also have an impact. That's the image that scientists used to have. People used to be mathematicians and an engineer and this and that and that. And it was all about making a value to society. And we kind of lost a little bit that role. I want to share another example now of things that work, and hopefully it's inspiring to some of you, to all of you. And that is the problem of neonatal mortality. When a baby is born before 9 months, it's a hard moment. If there is not an incubator at hand, 90% of the kids die, basically. What we do in our countries, developed countries, is that we have incubators. And when there is an incubator, 90% of the kids survive. So an incubator is literally the difference of life or death for these neonatal babies. This is something we should work with, and we try to fix it. And the frustrating part to me is that all of you and myself have in our heads the key to solve this problem, the scientific fact that makes this solvable. But because of the way we understand scientific facts and we understand how science is, it just doesn't come through. And it only came through another friend, Jane Chen, who started a company to look at these issues. And I'm going to try to walk through here and see where you see the light of where this fact is that is in all your heads to save the lives of 90% of babies. Because in a developing country, there are no incubators. And if there are incubators, there is no electricity. And if there is electricity, probably it breaks down and there is no spare parts, or they don't know how to use it. So the key here is constant temperature. A baby needs to be in constant temperature because they cannot regulate their temperature yet. Constant temperature. All of you have seen ice melt. When it's hot, it melts faster. When it's cold, it melts slower, right? That's it. All of you in your heads know the concept of melting, a transition from solid to liquid. And in physics, we call that transition phase. And one of the properties of transition phase is that the temperature is constant. There is no ice above 0 degrees. There is no water below 0 degrees. It's impossible. If you have water and you put it very cold, it's going to make ice super quickly. That's the key. The solution to the neonatal mortality, or one of the possible solutions, is to find a material who changes transition at 37 degrees. Works. You put wax on a plastic sleeve, you put it in boiling water with fire or whatever it is, you wrap it with a cloth, and then you are guaranteed by the laws of physics that that temperature for several hours is going to be exactly what the baby needs to survive. No electricity, no incubators, no nothing like that. But what happens? People who know about transition phase don't know about problems in development. People who have to know about problems in development don't typically know about, or don't realize that there is this process. So when I think of what I call impact science, it's these kind of things. How can I try to discover these kind of facts that can make the world really a different place and can really save the lives of a lot of people? That's what I've been trying to do. That's the reason I left the postdoc and went to the World Bank and worked with some of you, like with Eric, to work with drones on women's right to land titles in Kosovo and all these things. It makes absolutely no sense in the classical image of a scientist that is so, because they know a little bit of the reality, the segmented reality, and they are ruler experts in this very little thing. I say that to get there, you gotta have skills, powerful skills. And then I want to use those skills for any other things. And that's what I've been doing for the last 7 years. On the World Bank or in Bhutan, I'm basically traveling to figure out how I can identify this additional role of science, how can I identify how to create these type of scientists, how the supply of them, but also the demand. How, if you're a manager for a company, or you are a politician, or if you are in government, private sector, NGOs, how your typical image of a scientist is probably that of a researcher. But if you have this image of a scientist as knowledge creators, as someone who has skills to drive impact, then we can start to use the diversity of skills, the diversity of who we all are, to then face the biggest challenges of our times. It's this diversity what drives, to me, real impact. And that, to me, ties back to what FutureTalks is to embrace the diversity. As my role as a scientist is to use my skills, not use my knowledge, for the real impact we see in the world. Thank you.
Thanks, Bruno. That was amazing.
Thank you.
I have only one question, but it might take you a while to answer. It seems that, with the internet, access to knowledge about some of the world's problems, access to sort of data and scientific evidence around some of those problems is more accessible than ever. Mm-hmm. Yet, we see in the West a rising anti-scientific movement, both in politics and with voters. Why do you think this is happening, and how can we prevent it? What can we do about it?
This is a really good question, and I'll try to make it short, but as you say, it's a very deep, convoluted answer. To me, part of the reason is the core of what I said in the beginning. If the value of a scientist is the knowledge creation, walking dictionary, that I have facts in my head that you don't have, and when I tell you, you're gonna be, better. So basically, a scientist, in many ways, saying, do what I say, because if you knew what I know, you would do what I say, right? And if that is the value of a scientist, of course, because that's what he says. I mean, chocolate is bad for cancer, or chocolate is good for cancer. But it's not about chocolate being bad or good of cancer. It's where this information comes from. How do we try to be skeptics of everything? Carl Sagan said this, that we need to be a skeptic, ask questions, have the curiosity here, not to absorb everything we hear. And that is a little bit personal responsibility to everything you hear, from whoever you hear from. There has to be some skepticism. But it's the scientists who have these advanced tools that should be at the use of this problem, not a blind trust of saying, hey, what is it, chocolate good or bad? And you say good, and you say bad. I think that's a little bit where it goes a little bit to the core of why there is this erosion of trust, because if fact is the source of the trust, facts are easily faked. You just say it's something else. But if it's about the whole skill, it's about processing the information, then it's much harder to fake that trust.
Thank you again.
Thank you.